Welcome to Civil Engineering Licensure Examination Reviewer for practical questions on mathematics. Litton's Problematical Recreations, Part 1. Problem number 1. Rufus T. Flypaper drives 2 miles to work every morning. Very precise, he knows he must average 30 miles per hour to arrive on time. One morning a woman driver impedes him for the first mile, cutting his average to only 15 miles per hour. He quickly calculated his proper speed for the rest of his trip to arrive on time. Assumed that his car could do 120 miles per hour. Could he drive on time? The correct answer is no. He has already used 4 minutes, the time that he has to go the whole 2 miles. Problem number 2. A hunter wished to take his one-piece rifle on a train, but the conductor refused to permit it in the coach, and the baggage man could not take any article whose greatest dimension exceeded 1 yard. The length of the rifle was 1.7 yards. What could the hunter do? The correct answer is, he could put his gun diagonally in a cubicle box, 1 yard on a side. Problem number 3. Stations A and B are 120 miles apart on a single-track railroad. At the same time that a train leaves A for B at 25 miles per hour, a train leaves B for A at 15 miles per hour. Just as the first train leaves A South American butterfly flies from the front of the engine straight toward the other train at 100 miles per hour. On meeting the second train, it immediately turns back and flies straight for the first train. It continues to fly back and forth with undiminished speed until it is crushed in the eventual collision. How far the fly flow? The correct answer is 300 miles. Problem number 4. A man walks 1 mile south, 1 mile west, then 1 mile north, ending where he began. From how many points on the surface of the earth can such a journey be made? There are more than one. The correct answer is infinite. The journey can be completed by starting it at an infinity of points. One such point is the North Pole, all others lie in the neighborhood of the South Pole and require 1 or more complete westward trips about the pole. Problem number 5. In the game of Stogie, 2 players alternately place cigars on a rectangular table with the restriction that each new cigar must not touch any of the previously placed cigars. Can the first player assure himself of victory if we define the loser as the first player who finds himself without sufficient room to place a cigar? The correct answer is yes. The first player should appropriate the only unique point by placing the first cigar vertically on its flat end over the center of the table. From then on, he can counter each of his opponent's moves by reflecting them through the center of the table. Problem number 6. A bricklayer has 8 bricks. 7 of the bricks weigh the same amount and 1 is a little heavier than the others. If the man has a balance scale, how can he find the heaviest brick in only 2 weightings? The correct answer is 3, 3, 2. He divides the bricks into 3 groups of 3, 3, and 2 bricks. Then he weighs the 2 sets of bricks against each other. If they balance, then the heavier brick is in the group containing 2 bricks, which another weighing will simply tell. If they do not balance, then he weighs 2 of the group that was heavier on the first weighing. If these 2 balance, then the heavier brick was set aside. If they do not balance, then the scales tell which is the heaviest. Problem number 7. Maynard's grandfather clock is driven by 2 weights, one for the striking mechanism which strikes the hours only, the other for the time mechanism. When he hears the clock strike his bedtime, he immediately winds the clock and retires. After winding, the weights are exactly opposite each other. The weights are again opposite every 6 hours thereafter. What is Maynard's bedtime? The correct answer is 9 p.m. or 3 a.m. The weights are opposite immediately after 3 and 9 o'clock a.m. and p.m., so Maynard must retire at 9 p.m. or 3 a.m. Problem number 8. The game reverse tic-tac-toe, known to some as toe tactic, has the same rules as the standard game with one exception. The first player with 3 markers in a row loses. Can the player with the first move avoid being beaten? The correct answer is, he takes the center square and then counters each of his opponent's move by taking the diametrically opposite square. Problem number 9. Using graph paper to simulate a board of 64 squares and starting anywhere, is it possible to move a knight to all squares without touching the same square twice? Move can be made from A to either B, XXA, BXX, XBX. The correct answer is yes. Problem number 10. Dr. Frobisher LaRouche, the noted mathematician, was shopping at a hardware store and asked the price of certain articles. The salesman replied, 1 would cost 10 cents, 8 would cost 10 cents, 17 would cost 20 cents, 104 would cost 30 cents, 756 would also cost 30 cents, and 1072 would cost 40 cents. What was Dr. LaRouche buying? The correct answer is 10 cents per number. Problem number 11. Find 1000 consecutive non-prime numbers. The correct answer is 1001 factorial plus 2, 1001 factorial plus 3, to 1001 factorial plus 1001. Where n factorial plus a is divisible by a as long as a greater than 1 and less than n plus 1. Problem number 12. 2 squares are removed from opposite corners of a checkerboard, leaving 62 squares. Can the checkerboard be filled with 31 dominoes, each domino covering 2 adjacent squares? The correct answer is no. Removing opposite corners leaves 32 squares of one color and 30 squares of another color. However, each domino covers 1 square of each color. Problem number 13. Assuming the sun rises at 6 a.m., sets at 6 p.m., and moves at a uniform rate, how can a lost Boy Scout determine south by means of a watch on a cloudless day? The correct answer is, align the hour hand with the sun's azimuth, and south will be midway between the hour hand and 12. Problem number 14. What letter follows O, T, T, F, F, S, S, E? The correct answer is N. If we consider the letters as the first letters in 1, 2, 3, 4, 5, 6, 7, 8, and 9. So, N for 9. Problem number 15. The numbers are divided into 3 groups as follows: 0, 3, 6, 8, 9. In the first group, 1, 4, 7, 11, 14. In the second group, and 2, 5, 10, 12, 13. In the third. In which groups would 15, 16, and 17 be placed? The correct answer is 15 and 16 in the third group, 17 in the second group. The first group consists of numbers written only with curves in a certain type of style. The second group consists of numbers written only with straight lines and curves. Therefore, 15 and 16 would be in the third group and 17 in the second.